Okay, good day everyone. Today we're going to discuss about we have the dot product. Okay, so that product is chapter 8.4 or unit 4 of algebra 2. So that product defined as if A or vector A is equals to A1, we have A sub 2 and A sub 3, and vector V is equals to B sub 1, B sub 2, and B sub 3, then the dot product, we have the dot product of A and B is the number. We have B is number A times B. So it will be given us, we have A times B is equals to A sub 1, B sub 1 plus A sub 2, B sub 2 plus A sub 3 times B sub 3. So therefore, to find the dot product of A and B, so we will have to multiply A and B, and then we will add the next, we have values of A and B, so A sub 2, B sub 2, and then A sub 3 and B sub 3. So the resulting, we have the result of this dot product is not a vector, so the result is a real number. So the result is we have a real numbers, and sometimes we call this one as a scalar. We have scalar product. For 2 dimension, so we have vector A times vector V, so there will be 2 dimension, times we have vector B, so it will be A sub 1 times B sub 1 plus A sub 2 times B sub 2. So therefore, it's almost the same as the 3 dimension, but this one is just only 2 dimension. So therefore, we will have to multiply A1, B1 plus A2 and B2. So the result will be a real. So these are the properties of the product. Okay, properties. Okay, number 1, we have A times A, or vector A times vector A, so we will have magnitude of A squared. And then for number 2, we have A times B is equals to B times A. And then number 3, we have A times, we have B plus C is equals to A times B plus A times C. And number 4, we have CA times B is also equals to C times, we have A times B, or it is also equal to A times CB. And then the last one, we have the 5th one, A times 0, or 0 times A is equals to 0. So you can pause the video so that you can copy or you can take down notes for we have the properties of that product. Okay, so it's time now. So we have to give some examples for we have that product. So for example, find that product the following vectors. Okay, number 1, we have A is equals to 2 and 4, and B is equals to, we have 3 and negative 1. So we will have now A sub 1, so we have A1, B1 plus A2 times B2. So therefore we will have 2 times 3 plus we have 4 times negative 1. So therefore we will have 6 minus 4, which is the vector nor the answer of this one is a real number, which is positive 2. Okay, next example. For example, we have given negative 1, 7, and 4. And then the other vector given is 6, 2, and negative 1 over 2. So what is the dot product of the two vectors? So we will have now, this one is a 3-dimension. So therefore, we will have now A1, which is negative 1 times we have 6. Okay. Plus we have, okay, plus 7 times 2, and then plus 4 times negative we have 1 over 2. So therefore we will have now as negative 6 plus 14 plus we have 2. So therefore from here we will get now equals to, we have 6. Okay, so this one is negative 2. Okay, next example. Okay, next one, we have given A is equals to 3i plus we have 4j, and then B is equals to 5i minus 3j. So remember that I and j are the components of x and y. So I represents our component of x, j is a component of we have y. So therefore we can solve that one as we have A times B is equals to 3 times 5 plus 4 times we have negative 3. So therefore we will have now 15 minus 12. So we will get equals to positive 3. Okay, next example. So for example, given, okay, given A is equals to, we have 5i minus 6j plus 5k, and then B is equals to, we have 7i plus we have 4j minus we have 6k. So therefore this one represents for x, y, and z or z. Okay, so therefore we will have now A times B, or vector A, the dot product of A and B is equals to A sub 1 B sub 1 plus A sub 2 B sub 2 plus we have A sub 3 times B sub 3. So therefore we'll have now as 5 times 7 plus negative 6 times we have positive 4, and then plus we have 5 times negative 6. So therefore we will have now as 35. So positive negative, so therefore we will have now as negative 24, and then minus we have 30. So therefore the answer now is equals to 54. 54, we have 35 minus 54. Okay, so therefore we will get now as negative, how much is that? Negative 19, right? Okay, you can pause the video so that you can take down notes. Okay, so the next one, what if we have angle between the two vectors? So for example, if we have the theta is the angle between, we have the vector A and we have B. So then we will have now as A times B, vector or dot product of A and B is equals to magnitude of A times the magnitude of B cosine we have theta, or we can have now as cosine theta is equals to vector A or the dot product of A and B over the magnitude of A times the magnitude of we have B. Okay, so for example, okay, given that, okay, for example, given A is equals to 2, 2, and negative 1, and B, vector B is equals to 5, minus 3, and 2. First thing we'll do is we have to find first the magnitude of A and magnitude as well of B. So therefore, the magnitude of A now is equals to the square root of 2 squared plus 2 squared plus negative 1 squared. So that will be equals to 4 plus 4 plus 1 is equals to 9. So therefore that is equals to 3. And then the magnitude of B, okay, the magnitude of B now is equals to square root of 5 squared plus we have negative 3, okay, negative 3 squared plus 2 squared, that is equals to 25. We have 34, and plus 4 we get square root of 38. So what is the angle between the two vectors? So therefore we'll go now as cosine theta is equals to the magnitude of A and B. So therefore A and B. So therefore we have to solve as well. We have the dot product of A and B. So first we will solve first. A times B is equals to, because this one is the dot product of A and B over the, we have magnitude of A and magnitude of B. So we have the magnitude, so we have to find the dot product. The dot product is equals to, we have 2 times 5 plus we have 2 times negative 3 plus we have negative 1 times 2. So therefore we will have now as 10 minus 6 minus 2. So therefore we have positive 2. So therefore now we will get as 2 over 3 square root of 38, because the dot product is 2 and then the magnitude is 3 and 38. So to find the theta, we will have now the arc cos of, we have 2 and square root 3 square root of 38, which is equal to approximately we have 1.46, or it will give us 84 we have degrees. So to find the angles between the two vectors, you have to solve first the dot product of A and B, and then after that we have to find the magnitude of A and B as well, and then you're gonna do the theta and then the arc cos of this we have value. So that's all. Thank you so much.